Okay guys, let's continue. Now we have another problem. Find value of Joseph's number for 715 and 260. So as you remember, Joseph's number in closed form is given by this, right? 2 to the power of m plus l equal 2 times l plus 1, and we have as well the condition that is m greater or equal than 0 and l is between this. Okay, now we have to express 715, right, as a power of 2 plus some integer l. For that, we need to look for the closest or the highest power of 2, which gives us closest number to 715. So in this case, we're going to write that 715 is actually the closest power of 2 is 9. So 2 to the power of 9 is 515, right? So 512 plus 203. So 512 is 2 to the power of 9 plus 203. So now we expressed 715 as a power, as a 2 to power of 9 plus some integer. Okay, now this format, okay, corresponds to this format, and therefore now we can apply the closed form for Joseph's number. So that is j of 715 will be equal to j of 2 to the power of 9 plus 203. And we only care about this integer value, right, which corresponds to L. So we're going to write 2 times 203 plus 1, which is going to give us 407. Okay, in the same logic, let's try 260. So j of 260. Now the closest or the highest power of 2, which is closest to 260, is power of 8, right? So 2 to the power of 8 will give us 256. So I'm going to write 2 to the power of 8 plus, so this is 256 plus, to get 260, we need to add 4, right? Okay. Now, therefore, by Joseph's number's closed form, we can say that this is equal to 2 times 4 plus 1, which is equal to 9. And that's it. Okay, let's consider the next problem. Now we can also express, okay, Joseph's number in binary form. So first of all, let's consider definition. So the binary form definition for integer n is given by this, right? So bm, bm minus 1, and so on until b1 and b0. So this is in binary form. In this case, this b, right, these b's, they either could be 0 or 1, since we're talking about binary form. And bm will be always 1, so we always want to start with 1, our binary number. So either this, or alternatively, we can express it in this form, right? So we can say that what this means is that to this b to the power, b sub m corresponds 2 to the power of m, to b sub m minus 1 corresponds 2 to the power of m minus 1, right? So we're adding up all these numbers to get at the end this value n. And the power, right, power of m, we choose it, the highest power of m, the highest power of 2, which is closest to n, as in the previous example. Okay, let's consider now example. Write 78 and 142 in binary form, and then find the Joseph's value in binary form as well. Okay, so 78. Now we're gonna look for the highest power of 2, which is closest to 78. So the highest power of 2 is going to be 6, right? 2 to the power of 6 gives us 64. So therefore, I'm going to write 2 to the power of 6, right? So I'm going to put over here 1, which means that I'm counting this one, right? So 64 is still less than 78, and it's the highest power of 2, which is less than 78. Now, the next value, by definition, right, should be 2 to the power of 5. So 2 to the power of 5, which is 32. So now we have 64 plus 32, which is 96 and greater than 78, right? So therefore, what I say is I do not count this, so I put 0. So I'm not counting this 2 to the power of 5. Next is 2 to the power of 4. 2 to the power of 4 gives me 16. 16 plus 64, right? So this is 64, okay, will give me 80, which is greater than 78, and therefore I will not count it, right? So I do not want to take it. Next power of 2 is 2 to the power of 3, which is 8. 8 plus 64 is 72. So it's less than 78. So I can take it, right? So I will count it. You know, over here, let's say plus 8. Next is 2 to the power of 2, which is 4, right? So I have 64 plus 8, 72 plus 4, 76, still less than 78. So I will count it, and I will put 1. Next is 2 to the power of 1, right? I have 72 plus 4, 76 plus 2, 78 exactly. So I will count this one. And at the end, I have still the B0, which corresponds to 2 to the power of, right, 0, which is 1. But if I count this one, I'm going to get 79. So I will not count it. I will put 0 over here. And therefore, okay, I can write this in binary form like this. 1. So I'm only taking this binary values. 1, 0, 1, 0, right? So I have 1, 0, 0, 0. So 3 zeros. Sorry. 2 zeros. 1, 0, 0, 1, 1, 1, 0. So this is the binary form of 78. Now let's find Joseph's value, okay, of this binary number. As you've also seen in the lecture, right, we have a small theorem which allows us to find Joseph's value of a binary number as well. So by that theorem, we're going to say that J of this binary number 1, 0, 0, 1, 1, 1, 0 is just simply going to be 0, 0, 1, 1, 1, 0, 1. So remember that this one at the beginning just goes to the end by that theorem. Okay, now what can I can write this one. I can drop these 2 zeros at the beginning, right? Because we want to start our binary numbers with 1. And since in this case these 2 beginning zeros do not carry meaning, right? I will drop them and write it like this. Okay, so this is the Joseph's value of this binary number. Now let's check it, if it actually corresponds to the Joseph's number of 78, right? So now let's convert this back to, let's convert this back to 2 to the power of 6, let's convert this back to a number, okay, in a standard form. So this will be starting with 1. This 1 corresponds to B0, right? So which means that I have 2 to the power of 0 plus, next is 0 multiplied by 2 to the power of 1. Next I have 1 times 2 to the power of 2. Another 1 times 2 to the power of 3. And another 1, 2 to the power of 4. Which is, so I have 1, 4, 5, plus 8, 13, and plus 16 will be 29. So this number corresponds to 29. This binary number corresponds to 29. Now let's check it. We have J of 178, okay, which can be written as a power of 2 plus some integer, right, in this form, 2 to the power of 6 plus 14, right? So we have 64 plus 14, 78, which is by the theorem of Joseph's number for closed form will be 2 times 14 plus 1. So this is 28 plus 1 will give us 29. So exactly what we got over here. Okay, let's try 142. So 142 in binary form, we're going to give it like this, right? What is the closest or highest power of 2 which is closest to 142? So it's going to be 2 to the power of 7, right, which is 128. Now next, by definition, right, the power of 2 decreases. So the next power of 2 is 6, which is 64. So you have 128 plus 64, but already greater than 142, right? Therefore, I will not count this one. And next is 2 to the power of 5, which is 32. So I have 32 plus 128, right? It's going to give me 160, which is greater than 142. So therefore, I will not count this. Again, I put 0. Next is 2 to the power of 4, which is 16. So 16 plus 128 is going to give me 144. So still greater than 142. So I will not count this one. I will put 0. Next is 2 to the power of 3, which is 8. Now 8 plus 128 is going to give us 136. So I will count this one and I will put 1. So the next is 2 to the power of 2, which is 4. Again, I'm going to count it. So I have 136 plus 440. And the last one is going to be, not the last one, one of the last, which I'm going to count as well. And the very last one is 2 to the power of 0, which is 1. But if I count it, I'm going to get 143. So therefore, I will not count it. And I have over here in total, right, 142. And this value, right, in binary form will look like this. 1, 0, 0, 0, 3 zeros. And then I have 3 ones, 1, 1, and 1. And at the end, I have 0. So this is the binary form of 142. Now, if we're going to do find the binary Joseph's number of this binary number, what we're going to do is we're going to write this as following. So by that theorem is this 1 at the beginning just goes to the end, right? And the Joseph's value of this binary number equal to 0, 0, 0, 1, 1, 1, 0, 1. And I can drop these 3 zeros at the beginning, right? Because they do not carry value in this case. And I will write 1, 1, 1, 0, 1. Now we can see that this is actually same as this one, right? Which is equal to 29. So therefore, this corresponds to 29. And if we check it again, we can see that j of 142 is actually equal. First of all, we're going to write it as a 2 to the power of 7 plus 14, right? And by this formula, we can see that this will be equal to 2 times 14 plus 1, which is equal to 29. Exactly what we got. So this is it. Thank you all. See you next time.